Hi, so my name is Smriti. I am born and brought up in Delhi. So I've done my bachelor's from Maitri College in chemistry and MSc in chemistry from Jamia Hamdard. And then I did my B.Ed from MDU, and then I started working as a research scholar with IGNU in collaboration with CSIR. And also, I work as a freelancer, scientific writer, content creator, and I've also worked with Unacademy previously for about 1.2 years for K-12 category as a plus educator. So I think I would be a good fit for this role as I have already experienced uh, all the everything that goes behind the setup and how to interact with the students, how to be more expressive, and how to know and solve their doubts. So let's move forward. And talking about my content plan for 100 hours for NEET UG chemistry. So I'll start with the first week that I start with the basics. Basic concepts of chemistry and states of matter would be my first priority. So, starting off for 2 hours class would be for the introduction to chemistry only. This will include all the atomic structure, periodic table, chemical bonding, which are the basics that you start from 11th standard onwards. So, states of matter also include some basics, so I have included in the first week only gases, liquids, and solid for about 4 hours. So, solutions and colloids, types of solutions, colligative properties, colloidal system would be for 4 hours. And this would be very specific chapter, so it will come after it. Week two, since I have already introduced atomic structure introduction, I will move forward. And for week two, I have atomic structure, chemical bonding, and thermodynamics in it. So we have in this, the atomic structure would include quantum numbers, electronic configuration, periodic properties about 4 hours. 6 hours for chemical bonding and thermodynamics would be the starting from the basics. We'll move further. And then week three will be chemical kinetics and equilibrium and redox reaction, about 15 hours. I have distributed them accordingly. Chemical kinetics itself is a very big chapter, so I've taken 6 hours. Chemical equilibrium is for 6 hours. Redox reaction is a very small topic compared to others, so I've taken 3 hours for that. Then we have week four planned for chemical reaction or organic chemistry. So I'm starting off with organic, and this would take about 20 hours of classes. So this is the whole schedule for week four, week five, week six, and week seven. Then again, I'll come into the physical part that is solid state and chemical thermodynamics, surface chemistry, which will include now the specifics and the important topics which comes for more marker in the NEET entrance itself. Now, for the week 8, week 9, and week 10, all the remaining chapters would be done, like alcohol, phenols, and ethers. And then we have coordination compounds. And for all the classes, starting off with the theory itself, I will move forward from CBSE, from the syllabus, NCRT syllabus, to doing questions, MCQs related to the entrance, and so on. So this will include practicing of questions also. Now, uh, I'll start my demo. So I've taken a topic of surface chemistry, and starting off with the basics again, I have to start with what is absorption and what is adsorption. So let's start. Okay, so in the adsorption, since this chapter is focused on adsorption, and we are already familiar with the word absorption, right? So we know what is absorption. We always say absorption, इस पे absorb हो गया है, इस पे absorb हो गया है. So yeah, we know about like we take a sponge and we put it in the water. We see that all the molecules, water molecules, are absorbed in the bulk itself. So we say that it goes inside the bulk, right? We say on the surface and inside the bulk also. So let me show you. Okay. So as you see in the absorption part, we talk about on the surface and also in the bulk. It goes both ways, surface and bulk properties, right? That is absorption for you. We already know that. But what is adsorption? Why? What is the D here? So the adsorption here means that we are only talking about the surface properties, surface phenomena, I should say. So we are only focused on the what is happening over the surface, right? This is my pen. This is my pen holder. So basically, what you're doing is you're talking about the surface, only surface. We don't want to know what is happening inside the bulb, right? So I'll just keep my tab here. So absorption, right? So what is the basic difference between them? It is the process by which atom, molecules, or ions enters a bulk, right? So I said it is a bulk phenomena. Absorption is the accumulation of any molecule you're talking about, whether it's gas or any liquid, anything you're talking about, you are getting it absorbed on the surface, right? Only on the surface, whether it's because of the chemical bonds or any physical interaction, physical force. We'll talk about this later, but yes, absorption is only a surface phenomena. When you talk about absorption, it is a bulk surface phenomena. I've already said this. It is an endothermic process. Absorption takes much longer. And also, in terms of enthalpy, you have to give the energy. It is an endothermic process. What do you mean by endothermic process? So basically, endothermic process is when the process requires some external heat, right? You have to give the heat so that the process can proceed. But in case of exothermic reaction, which is adsorption here, in exothermic reaction, what you see is a release of heat. So whenever there's an adsorption going on, there will be a release of heat. You will see that it is releasing itself. So yes, that is an important difference between absorption and adsorption. Then we have it is same throughout the material. Yes, when you say absorption, it will be throughout the bulk. It will be uniform, and in adsorption, concentration will be limited to the surface. Okay, so that will be different from the bulk itself. It is not affected by temperature. Absorption, since it will not be affected, it will not increase or decrease. But yes, adsorption will increase and decrease, or it can also get desorbed, right? It can also remove the molecules from the surface because of the temperature fluctuations. So let's move on to what are the terms related to this whole phenomena. So we have adsorbate and we have adsorbent. Very important, actually. When you say adsorbent, you mean a certain material that will act as an adsorbent that will show you the phenomena, right? And all the molecules will come on the adsorbent, right? So let's just talk about the adsorption here. So in adsorption, we have two terms, adsorbent and adsorbate. So in the adsorbate itself, we are talking about the, let's say we are talking about some molecules, right? So let's just say it is some molecule, whether it's solid, liquid, whatever. It's a molecule. We're talking about the molecules, incoming molecules. That is adsorbate. Right. When we talk about adsorbent, that will be the material on which it is getting adsorbed. Right? That will be the material itself. So when we are talking about adsorbent, refers to a material that is adsorbed on any surface. For example, if a gas is getting adsorbed on the surface of a solid, that the gas itself is an adsorbent, and here the solid will be adsorbent. So I hope that is clear. And the adsorbent is a substance on the surface which adsorption occurs. That is self-explanatory. So the adsorbent might be either solid, yes, or metal, or a liquid. It could be a liquid also. Silica, animal. You must have seen adsorbents many times, actually. We have seen silica powder in labs also, you must have seen silica powder, very easily available. So silica powder and charcoal. We see so many cosmetic masks, and we see everywhere it is written charcoal, charcoal. This will help you remove this certain impurities and whatever. That is also adsorption process, right? So charcoal activated carbon is basically that charcoal, silica, zeolites also, they are some of the traditional adsorbent actually, right? If I talk about zeolites, if I talk about activated carbons, right? And what else? Clay. Yes, many cosmetics are also also made of clay minerals. So yes, all of this are showing you adsorption process, and all of these are adsorbent, right? They have porous structure inside, and when they have porous structure, surface phenomena is greatly shown by them because of the porous structure. So yes, these are some of the very traditional adsorbent. Now the material science has evolved and we have new materials, new porous crystalline materials as well, but I'll talk about this later. Okay, so we have desorption and absorption also. When you're doing the adsorption is done, you might want to recover the adsorbent, right? You might want to do is like certain molecule is already adsorbed. So you maybe want to use that particular adsorbent again for some other molecule, right? It is also has a great affinity for some other molecule, let's say, right? Let's say this is radioactive iodine and you want to remove it from water, right? Or from any medium, right? It's a radioactive thing you want to remove. And this particular adsorbent, this is the adsorbate and this is adsorbate, right? Let's just write uh, right, AB for adsorbent, and let's just see AD, adsorbate, right? So basically what you're doing is iodine will get adsorbed and this is the whole material that is the adsorbent, right? This is bed and this is adsorbate, right? Adsorbate. Okay, this is the short version I've done. Okay, so basically you want to remove it. And how you will do it, that will be a desorption process. So desorption is a process of removing an adsorbed material from the surface of adsorbent. This can be accomplished by increasing or decreasing system's pressure or temperature. So this is the whole process, right? And absorption we have already discussed. So this was the thing I was discussing, that you see it on the surface. You don't see it on the bulk, right? Let me change the color. So yeah, it is a surface phenomena, but how do the molecules feel on the surface? So basically, the pressure on them, the force on them, I should say, force is not equally distributed as compared to the bulk, right? If you see bulk is getting stretched out from all the directions, right? But when you see the molecule on the surface, it is like partly it is getting stretched from because of the bulk material already there. They're forcing it inwards. Like there's a force of attraction inward, but there is the halfway, the air molecules are not that, like it's not showing that much attraction, right? So above part is already gone, but there's some force of attraction because of the bulk, right? So if you compare this one and two, there's a huge, huge difference in the force of attraction. So yes, they feel the surface tension. That is known as the surface tension, right? You must have seen that when you dive from a certain height, you have to do like this to like break that surface tension. So that is the whole thing that happens only on the surface. So this is something that we're talking about only on the force, right? Okay. So last topic would be the applications of adsorption. A bulk of charcoal, I have already said that in cosmetic chemistry has a huge application, right? And then we have gas mask, of course. I don't have to say this. Gas mask. If you just put a membrane, like let's just say I have an adsorbent and I've made it into a filter or a membrane, and only the water could pass and not the impurities. And those impurities can be anything you're filtering out. It could be a dye, it could be any organic dyes. You must have seen industries, they have to treat the water before releasing it. So it could be organic dyes or heavy metals that you don't want. So you can make a membrane of adsorbent and those particles won't pass through, they will get adsorbed. So that is one of the important application that is being used till date. So then we have dehumidification. Yes, certain materials could be adsorbed. Whole phenomena is going on adsorption. So electrical equipment, silica gel is also utilized for dehumidification, color removal from the solutions. Like I said, dyes, anything, right? Could be adsorbed on the charcoal or whatever affinity is there. Like calcium chloride is very good for absorbing water vapors, right? So there's so many applications, right? So these are all the things that I wanted to discuss with you. Thank you so much.